Let's suppose we're given a problem. We have two firms, Alex's firm, that's what A stands for, and Bob's firm, or B. And suppose they want to make a cartel, or in other words, they want to collude together to restrict output and raise prices, rather than compete against each other, essentially acting like one gigantic merged firm. Okay, and then so the cost equations are given by QA squared for Alex and 1/2 QB squared for Bob. Or in other words, Bob's costs are about half as much as Alex's costs. And here's market demand. So the total quantity demanded multiplied by 2 subtracted from 21 equals the market price. So now off of these three equations, we want to set up the cartel problem. Or in other words, what is the optimal quantity that the cartel should produce in order to maximize their profits? So, what we want to do is first set up the problem, the cartel's problem, and a good cartel will always want to maximize its profits. Okay? That's all the cartel cares about, is how much profit it makes. So, the cartel's profits are given by total revenue minus total cost. Okay? Now, total revenue is just price times quantity. The quantity of widgets sold by the cartel multiplied by the price of each unit sold. Total cost, so we're going to subtract total cost. Total cost is the cost of Alex's firm plus the cost of Bob's firm. So this is profit. Okay. We can do even better than this though, because big Q, we should note, big Q is just little QA plus little QB. In other words, total market quantity produced is given by Alex's production of widgets plus Bob's production of widgets. So, we can set up the problem like this. Maximize total revenue is P times Q. We have this P here. We're going to substitute in this P here for that P. Okay, so 21 minus 2. Now when we see this big Q, we're going to substitute in these two little q's. So that gives us negative 2QA minus 2QB. Okay, so I'm just sticking this big Q equal to these two little q's into this equation, and that gives us 21 minus 2QA minus 2QB once you distribute the 2. So this right here is price. Now we need to multiply by quantity. But what is quantity? That's just little QA plus little QB. Now we subtract the cost of Alex minus CA. CA is QA squared. And the cost of Bob. Alright. So I distributed the negative here and substituted in the cost equation of Alex and Bob. And now we need to include our choice variables, QA and QB. These are called choice variables. Because this is essentially what the cartel has power over deciding. It can tell Alex, hey, you need to produce this many widgets, and Bob, you need to produce this many widgets, so that we can maximize profits. So this is the setup of the problem. Okay, and now let's solve it out. Solve. So, to maximize any equation, we need first order conditions. which means we take the derivative with respect to the choice variables, QA and QB, and set it equal to 0. So for the first equation, we are going to take the derivative of profit. Remember, this whole thing is profit of the firm, of the cartel. Let's take the derivative with respect to QA. And remember the product rule. Product rule says to take the derivative of two equations, we take the derivative of the first multiplied by the second plus the first times the derivative of the second. So, or we could just simplify this, but who wants to do that? So we take the derivative of the first with respect to QA, that's -2. Remember, we're taking partial derivatives. That's what this del letter means. So -2. Leave the second term alone, plus the derivative of the second, which is just 1. Leave the first term alone. The derivative of this with respect to QA is -2QA. The derivative of this with respect to QA is just 0. And then we set the whole thing equal to 0. For equation 2, we take the derivative with respect to QB now, the other choice variable. We get -2 times the second term plus 1 times the first term. Once again, just the product rule here. The derivative of this one with respect to QB is just 0. This one is minus QB, because the 2 drops out, cancels with the 1/2. This becomes -QB to the first power. Set that equal to 0 to get the first order conditions. So now it's just some algebra from here. The most tedious part of economics, algebra. So solving equation 1, or simplifying equation 1, we get -6QA minus 4QB plus 21 equals 0. If you don't believe me, do a little bit of algebra yourself. You'll see that that will happen. Okay, equation 2, simplifying that, you get -2QA, -2QA, so that's -4QA minus 2QB minus 2QB minus 1QB, so that's minus 5QB plus 21 equals 0. So now we just need to solve this 2 equations, 2 unknowns system of equations. There's many ways to do it. It just depends on what you feel like doing at the moment. Let's do standard substitution. So we'll take equation 1, solve for QA. You get just move the 6QA over here, divide by the 6. You get QA equals this. Now we can plug this into equation 2. So plugging into equation 2, we get minus 4 times QA minus 5 QB plus 21 equals 0. So now we just solve that, and we get, let's see, what do we get? More algebra. 16 QB minus 84 divided by 6 minus 5 QB plus 21 equals 0. Multiply everything by 6. We get 16 QB minus 84 minus 30 QB plus 126 is 0. Solve for QB, you get negative 14 QB equals 42. And then now you get QB is, with our trusty calculator, 42 divided by -14. And I did something wrong. Oh, yeah, that's right. Because here we have -14 QB, sorry, minus 42. So that's just 3. In other words, Bob's firm should produce 3 units of widgets. What does this tell us about Alex? Well, if you plug this back in up here, so you use this equation, you'll get QA star is -4 times QB, that's -12, plus 21 divided by 6 is 1.5. And so Alex's firm should produce 1.5. Now let's think about this for a second. Why should Alex produce less than Bob? Well, it comes down to their cost equations. Alex's costs are exactly twice as much as Bob's costs. So in equilibrium, it turns out that we want Alex producing exactly half as much as Bob. Alright, so now that gives us enough information to solve for the other equilibrium outcomes. So far we have QA star is 1.5 and QB star is 3. That immediately tells us that big Q star is QA plus QB, 4.5. Which immediately tells us that equilibrium price, which is given by this equation, 21 minus 2Q, is 21 minus 2 times 4.5. 2 times 4.5 is 9, 21 minus 9 is 12. And then we can even find individual firm profits. So, for example, the profit of Alex's firm, given that the cartel splits the profits according to how much each cartel produces. If it doesn't, say it gave all the profits to Bob, then, throw this out the window. But that is given by, once again, Alex's profits, total revenue minus total cost. In other words, total revenue, this, of Alex minus total cost of Alex squared. What I'm looking at here is that's the cost equation for Alex. This is the revenue equation for Alex. That is 12 times 1.5. Right? 12 times 1.5 minus 1.5 squared. That's the same as 1.5 times 12 minus 1.5, which gives you 12 minus 1.5 times 1.5. 15.75. And Bob's profits. Price times quantity, that's total revenue, minus total cost. His is 1/2 QB squared. So that's just 12 times 3. Remember, he's double Alex's quantity, minus 1/2 times 3 squared. That's 9 divided by 2. 36 minus 4.5. That's 31.5. So that solves the cartel problem of the oligopoly problem. To check out more videos for the quasi-competition, as well as the Cornell problem, Stackelberg leadership model, please check out the rest of my channel. Thanks.